In this video, we're covering differentiation of exponential functions. So I'm just going to jump in and go through a range of different exponentials and show you how we differentiate them. And the first one we're looking at is just e to the power of x by itself. So if I go to differentiate e to the power of x, so that means I've got y equals e to the power of x. I go to differentiate it. As it in the text said, the derivative of e to the x is itself. So what that means is dx equals ex. Nothing changes, it is itself. Now if I have the derivative of ae to the power of x, it's also the same. It doesn't need to change. So if y equals, let's say, 5e to the power of x, and I differentiate that, it's going to equal 5e to the power of x. All right? Next one, the derivative of e to the power of ax is e to the power of a. I don't really like that. How I like to look at it is if I have something like y equals e to the power of fx, some sort of function at the top there, the derivative is going to be the differentiation of that power and then e to the power again, e to the same function. So what I mean by that is if I do an example, let's say I have y equals e to the power of 6x, then my fx over here is going to be 6x. So if I differentiate that, I get 6. So when I go to do my differentiation of e over here, this is going to equal 6e to the power of 6x. And it fits what I drew on the left there, that formula. So that's a little formula you can use to do the derivative of something where it's not just an x on top, it has a coefficient, some sort of function. And that works for anything as well. So we're going to do some examples here. We have e to the power of x plus e squared, and I want to differentiate it. Now note, this is going to stay the same, so the x to the power of 2 is the only thing that's going to change. So if I go dy dx, e to the power of x is still there, but then I do need to differentiate the x squared, which is 2x, because remember the power comes out the front, and then you minus 1. Alright, we're looking at this one here. We do have to use a rule here. We need to use the chain rule. We need to use the chain rule here. So I'm going to use the shortcut method, which is the power comes out the front, the new power is the old power minus 1, and then we're going to multiply that coefficient by the derivative of the brackets. So that was a lot. So what I mean by that is dy over dx. The 7 up here comes out the front, so I get 7. We're going to times it by the derivative of what's in the bracket, so the derivative of ex plus 5, which is just ex. You rewrite the brackets, and then it's to the power of 6 now instead of 7 because you minus the 1 off. And if we simplify that down, we get 7e to the power of x, ex plus 5 to the power of 6. And next one we're going to look at here, we need to use the quotient rule because it's a fraction. And remember, that's y equals u over v. So in our example, I'll write the actual formula first, dy over dx equals, remember v always comes first with this one, minus there you go, and then we can just start doing it. So u is going to equal my e to the power of x, v equals 7x minus 3, so du dx equals e to the power of x because it doesn't change, dv dx equals 7, and then we can just substitute this into the formula. So we get dy dx equals 7x minus 3 to the power of times ex minus my u times my dv dx, which is 7, so times 7, and that's all over v squared, so 7x minus 3 squared. And I can simplify that a little bit just to make it a little bit tidier. So we get e to the power of x, 7x minus 3 minus 7ex over 7x minus 3 squared. All right. Next one, find the equation of the tangent to the curve, because remember, we're not just doing exponentials now, we're doing a lot of calculus things that we've previously learnt in other videos. So now we're adding all these just to exponentials. So again, we're going to start by differentiating this. So dy dx is going to stay the same. And then we want to find the gradient at that point. And over here, they've given us a coordinate we're going to use. So we're going to use that there, that 1. So let's change our x to 1. And we get dy dx equals negative e to the power of 1, which is just negative e. Now we're going to use the formula y minus y1 equals m x minus x1. And we're going to do our substitutions. So I do know that the coordinates were, if I can scroll down, 1 and negative e. So that was my x and that was my y. And the gradient was negative e. So y minus e equals x, take away 1. So we end up with y plus e equals negative ex plus e minus e minus e. So I end up with y equals negative ex.